Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Hi, my name is Aiman and I will talk about light and optics, specifically reflection and refraction. So before we start, I'd like to talk about what you will learn inside this lesson. So at the end of the lesson, you should be able to describe critical angle and total internal reflection. You should also be able to relate critical angle with reflective index. You also should be able to explain natural phenomena and applications of internal reflection. So before we start, let's go and watch a video, and I want you all to observe what is the phenomena is happening inside the video.
They're not uniting. No, you're still not connected. Here we go. Here we
It's a
go.
little temperamental.
There we go. There we go.
Okay, here we go. We're having a good time now.
So what is happening from the video that you just watched? If you answered total internal reflection, you are absolutely correct. But first, before we go on to total internal reflection, we need to revise. We need to look back at a subject on something called refraction. What is refraction actually? In definition, refraction is the change in direction of wave passing from one medium to another. I like to actually show an analogy of how does that happen, and that is called the car analogy. You can see here. So from the car analogy, you can see that a car travels in an angle towards a sandy surface, and one front of the wheel hit a sandy surface, causing it to slow down, but the other wheel keep on going on the fast rate, and due to that, the car actually turns when they change from pavement to sand. It is also happen in the same way for light. So as you can see here, light passing from air to glass block, and you can see there that the angle of incidence of the light are refracted differently in another medium, and that is a glass block. So there is two outcomes for refractions, and that is a light ray travels from a less dense medium to a more optically dense medium, causing it to reflect much closer to the normal line. And if the light actually travels from an optically dense medium to a less optically dense medium, it will refract outward away from the normal line. So what is optical density? Optical density or refractive index can actually be calculated by using this formula. As you can see here, as the reflective index increases, the refraction ray actually getting closer and closer to the normal line. You must be asking, what is the relationship between reflective index and the angle of incidence and reflective line? It actually can be explained through Snell's law. Wait, I'm sorry about that. That is actually the wrong Snell. So the actual Snell is the Snell law. So using the Snell law, you can see that there is a relationship between reflective index of two medium and also the angle of incidence and refractions of the ray. So now that you know all of that, you can actually try this exercise. You can pause the video and try it for yourself at home. I will give you the answer at the end of the video. So now that you know what is Snell's law, what is refraction, we will go to our next agenda. Before that, let's watch an experiment. As you can see from this experiment, the light is getting closer and closer to 90 degrees as the light is moving closer and closer to the other side. But as you can see over here, if you're observing that there is another faint light over there, and then as it getting closer to 90 degrees, it's getting stronger and stronger. And there is also a 90-degree refraction over here, if you can see. So what is happening inside this experiment actually? Why is there a 90-degree over there? Where does that other ray came from? I will tell you what is happening inside that experiment. What is happening is called total internal reflection. So what is total internal reflection? By definition, total internal reflection is where a ray of light is completely reflected within a medium, as you can see from this picture above. So from this slide over here, you can see it much more clearly from that experiment. Even though that experiment is actually amazing, it's great, but you can't see much the smaller details. So from this diagram over here, you can see what is happening. Why is there a 90-degree reflected ray? This part over here is called a critical angle, as you can see here. What is a critical angle, you ask? A critical angle is an angle of incidence where the angle of refraction is equivalent to 90 degrees. That's it. So if you derive the Snell's law, you can see that you can actually determine the reflective index of the denser medium. Now that we are almost at the end of the video, I will give you one last exercise so that you can understand it much better. You can pause the video to do the exercise, and the answer will be given at the end of the video. So you must be wondering, where can you see total internal reflection in real life? I can tell you. First is the formation of rainbow. The sun will refract inside the water droplet, causing the ray to split into 7 different colors. Inside the water droplet, total reflection also happening inside there, and another reflection causing it to split even more, and thus you can see the 7 colors in the sky. And also on hot days, you can see mirages. So how does mirages happen? As the air above the ground heating up, the hot air actually have lower density than cold air, thus forming layers of cold and hot air on top of the ground. From those layers, total internal reflection can happen, thus forming mirages. There is also an application for total internal reflection. First is for a periscope, where 2 prisms are used. From those prisms, as you can see from the picture over here, that there is an total internal reflection happening inside those prisms, bouncing from one prism to another and then towards our eyes. Next is fiber optics. Fiber optics have that outer cladding or outer layer that have higher density, causing the light to actually total internal reflection happening inside those fiber wires. Finally, as you can see over here, a cat eye reflection on the road, where the driver can actually see where is the line on the road at night. that is all from me. Thank you very much for watching, and assalamu alaikum warahmatullahi ta'ala wabarakatuh.